So let's talk about ordered pairs. This is the main thing we talk about, ordered pairs. So let A and B be sets. And then we could say, we can kind of label them. A is A1, A2, A3, like that. B is B1, B2, B3, like that. It could be infinite, it could be finite, it doesn't really matter, right? Then A cross B is the set of ordered pairs AB, where A is in the set A and B is in the set B. I.e., another way you can think about this is A cross B. You could write it like this. It's the set of all AB such that A is in A and B is in B. That's the way you can write it. We'll talk about set notation later. Or another way you can think about it, in our particular example here, is A cross B. So it's going to have A1, it's going to have A1, B1 in it, right? Because that's one example of a pair from A and B. Another example of a pair from A and B is A2, B1. Don't forget A1, B2. Don't forget A1, B3. Don't forget A3, B1. Don't forget A3, B2. On and on. All the possible pairs you can make, right? Where the first coordinate comes from A, because A is listed first here. The second coordinate comes from B, because big B is listed second. That's the ordered pair. That's all it is, right? Like whenever you write parentheses around two items like that with a comma between, that's an ordered pair. And it's called, it's an ordered pair because it's a pair of things, right? It's an ordered pair because XY is considered different from YX. And again, notice this is in general, right? So if X and Y happen to equal each other in that particular case, well, sure, this will be the same. But in general, XY is not equal YX. So, example of this would be if A equals 1, 2, and the matrix 1, 0, 0, 1, and B equals pi and E, well then A cross B would be the set. It's going to have 6 elements because there's 3 in here and 2 in here. And so you have 3 choices for the first coordinate of an element and 2 choices for the second coordinate. It's going to be 1 pi, 1 E, 2 pi, 2 E, 1, 0, 0, 1 pi, 1, 0, 0, 1 E. Make sense? It's an ordered pair.
Quick question.
Hit me.
So, like, I guess an observation that's worth noting, right, is that multiplication of sets or crossing sets is not commutative, right? Because of the ordered pairs.
Ooh. Excellent question, Alex. Talk to me after class.
Oh. Okay, and I think one other kind of quibble is like it's more correct to say there's only 6 unique elements, right? Because you could have repetition.
Yeah, sure.
Okay, cool.
It's actually bringing up some excellent points about identity and things like that, right? But yeah, there's 6 unique elements for sure. Like you could also represent 2 pi, right? You could write this as 1 plus 1 pi, right? Does that make it a different element because you listed it differently? There's like equivalence principle and stuff like that. Like in a certain sense, we think of 2 things that are equal as being the same thing. And so it's like, if you ever listed something twice, you just listed the same thing twice. It's kind of like, it's not like you listed 2 things that are equal, you listed the same thing. it makes any sense. But anyway, yeah, talk after class because it gets into isomorphism. But it's actually interesting. But anyway, so these are ordered pairs. Another example. Is anyone taking linear algebra?
Hey.
Who's that? Was that Afro?
Yes.
Afro, okay. Oh, Alex raised his hand. Nice. So you guys have probably seen this symbol right here. It's like the real numbers squared.
Yeah.
Has your professor talked about what that means?
No, not yet.
So the real numbers squared, the reason that's squared is because it's literally the real numbers crossed with the real numbers. It follows the same notation as actual numbers, right? Like repeated multiplication as an exponent. Same thing here. The real numbers crossed with the real numbers gives you r squared. And all this is all pairs
Real numbers?
of real numbers AB, where A is a real number and B is a real number. Here, the two sets happen to be the same. And that's all it is. It's all pairs of real numbers. That's what r squared is. And that's why it represents the plane. Because if you think about the xy plane, here's x, here's y, this is really just a collection of all of these points. Like imagine if I was able to do this dot uncountably infinitely many times, right? And do all these points in the plane. And what's each point? Each point is just has an x value and a y value where the x and y are real numbers. The plane is just the set of all x and y real numbers. It's the same thing. It's just a way to draw it. Fascinating. Sets, man. These are sets. Order pairs, all that. Any questions?
I have a quick question.
Yeah.
Is a set of an infinite amount of the same number equivalent to the set of just that one element? So like a set of an infinite amount of ones equal to just the set of one?
Yep, because all a set does, right? All a set does is it's a collection of things that are either in it or out of it. And so just ask the question, is one in or out? It's in, right? So having it multiple times doesn't really change anything. It's just like, it's like the way we list sets in our human world, we write things down so we can see which ones are in or out. But yeah, so it doesn't matter if we put two there, it's just saying it's in it once. Good question though. All right. If anyone knows how to code in Python, ordered pairs are tuples and sets are sets. So some things make sense.